refer back to old information while we're learning new. Renee and I had a little discussion right at the beginning of break right now about this curve. It was preceded by, Renee, what was the thought process that started? Check this out, this is huge. Beautiful. So you get a data point. And here's where the probability part comes in. You got one data point. You have to base off one data point, whether it's on this curve or some other curve. I can't reiterate enough, YouTube world. That orange curve is not fixed. I just slapped it to the left of this one because it appears to be to the left of this one. That goes what Renee's just talking about right now. So this guy right here, technically speaking, is slidable because we don't know exactly where it's centered. We do know where this one is centered because it's the null curve. It's what already is happening in the population. We're seeing that over decades and over centuries sometimes. Michael, go.
And it wasn't always necessary to look the same.
Yes, or no, I should say. Yes, that's correct. Because the shape is going to change based on the sample size. It might be taller than the other one. I think it's easiest to visualize when they're both the same. But yeah, that's 100% correct. I'm assuming it's a bell curve. I get the bell curve for free because of the central limit theorem. But you're correct in assuming if that's a population curve, it should be a lot tighter. But you got to remember that since these things are generally done in controlled studies, this is a sampling distribution of the study, which is most likely going to have a similar sample size to this one. Now, it might not have the same standard deviation, which is what Michael is getting at. If it's got a lower standard deviation, it's tighter in than a wider standard deviation. Good. But very often, you'll notice, sometimes the standard deviations are pretty close to each other. So very often, they do kind of look similar. But the problem with this one is you still don't know exactly what that one is. All you get is this data point. So you have to build the curve around that data point, so to speak. So Renee's question is, what's more likely? And this is right here. What's more likely if all you got was that data point? Is it likely that it's on this curve? Or is it likely that it's on some other curve?
I would say do it again.
Oh, of course, but you have to, right now you have to make a decision.
Why? Just do it again.
Because, what if your funding ran out? All you've got is this study. Make a call.
I feel like it's not fair to make a call.
That is statistics! Oh! That is statistics, which you're implying, and I love that you're implying it. Replication of studies should happen. Yes! This goes back to Michael Waller and the one sample size. I love you, Michael. The one skull size thing. It goes back to that. But if that's all you've got, make a conclusion. Who do you believe? Do you believe it's the same as this?
No.
No, it looks like this. But then you put that out there. You don't prove anything with that. You put it out as a result. And you hopefully somebody grabs it and replicates it. But it appears to be more likely that this bad boy is within 2 standard deviations of this curve than it is 2 standard deviations of this curve. Notice how I didn't draw that curve way the hell over here. Because then it would be just as unlikely to be on either curve. I drew it near where our data fell because most likely we didn't get n. Most likely we didn't get an outlier. We got a typical data point from some other curve.
I feel like...
Go ahead. Thank you, Renee, for that.
I feel like you're not necessarily all in the dark as far as a curve, because if you get that data point and you're kind of like, okay, what the hell? You're able to, since we were studying green tea, take all the countries that don't habitually drink green tea.
America, for example.
And then take a bunch of other countries that do habitually take green tea and look at the number that comes out every single year of how many people get breast cancer that hospitals, are putting out there.
That's good.
And then just averaging those to build a bell curve. I feel like you're not in the dark.
I'm with you with everything except the hospital bit. And here's the problem. Who is going to go to a hospital? Those who are so sick they can't fix themselves anymore. I'm case in point of this. I crashed riding my bike to work last Tuesday. I effed up something in here. I had Tomas kind of rubbing me out this morning.
Well, we're looking at...
But I didn't go to the hospital. You're not going to get my data point. You're going to get the extreme cases. I love what you're saying, Kate. It's anecdotal. That's how the belief starts. From all those anecdotal... No, I'm not downing you. I'm with you 100% except for the hospital bit. That's the data collection part. But I'm with you. Observe, and then create a study based on that observation by drawing a random sample.
People who have breast cancer are going to end up, hopefully, not always, being diagnosed at one point.
You would hope.
And
yes, of course.
And so rather than just taking 1,000, 2,000, 10,000 people and checking for breast cancer in increments all the time, just relying on what's already been done to start building your bell curve.
If you can justify that what has already been done, this is the only thing I'm picking on. The only thing I'm picking on. if what has already been done justifies a good random-ish sample of the population. As long as that's satisfied, I'm a happy dude. I love what you're saying. You're saying you're not in the dark. You're 100% correct. There's nothing wrong with anecdotal evidence until you try to prove something with it. If it's showing you a trend, then it's like, oh hell, we got anecdotal. Let's go and try to actually show it beyond a reasonable doubt. Does that make sense?
No, yeah.
So I love what you're saying. I'm not saying it's wrong. I'm just saying careful with the hospital records because a lot of times those people are so advanced along in their sickness that you're getting a skewed population, if you will. You're getting a skewed sample.
And also,
Plus you have a baseline to measure off of. Yeah.
And also in China, a lot of people can't afford to go to a hospital and they die outside. Yeah.
So not just the denial of going like I do because I'm hurt and I'm just going to deal with myself, but we can't get there. And you're assuming the hospitals actually take good records, which is hopeful.
Okay.
So I love what you're saying. We just got to make sure it's a good randomized sample is all. Good? Fair? Love it. Good. Now, one more article for you to read, to consume. Secondhand smoke. Secondhand smoke. The last one on the page. We'll have to shut the camera down while you get a chance to read that.